Hey everybody, and welcome back to one of my Math 8 SOL review videos. All right, this question asks us to identify each number that lies between 1.7 times 10 to the 0 and 195%. And by saying each number, there may be more than one of these that lie between there. So once we find one, we can't just give up. All right, so let's go ahead and first of all, and there are lots of different ways you can attack this problem, but uh, my advice would be to turn each of these values into a percent and then graph them on this little number line that I prepared down below to get a visual to see exactly where they compare to one another. So let's go ahead and begin with 1.7 times 10 to the 0 power. Let's go ahead and start that one. So 1.7 times 10 to the 0 power. Anything, by the way, to the 0 power, if you'll recall, is 1. So literally 1.7 in this case is simply being multiplied times 1, which gives us 1.7. 195% gets turned into a decimal, if you'll recall, by moving the decimal place 2 places to the left. And if there is no decimal place in view, we find it at the very end of the number, so I'll add the decimal place at the end of the number. And if we jump 2 places to the left, the decimal would move between the 1 and the 9, giving us a decimal equivalency of 1.95. So if I go ahead and graph them down below, let me go ahead and graph some values on here. We'll put 1.5, and we'll make that 1.6, 1.7, 1.8, 1.9, 2.0, 2.1, and 2.2. If I were to graph 1.7 on this number line, it would sit right on the 1.7. And 1.95, well, that's a little bit more than 1.9, but not quite 2.0. So it's somewhere between here. I'll go ahead and put a dot here to represent 1.95. So what we're trying to determine is which one of these values falls between 1.7 and 1.95, or 1.7 times 10 to the 0 power and 195%. So let's begin with 1.8 times 10 to the first. So 1.8 times 10 to the first power. Well, 10 to the first power is the same as 10. So literally we're multiplying 1.8 times 10. And if I use my calculator, I know 1.8 times 10 is the same thing as 18. And I know by looking at this graph that 18 is way bigger than anything on my graph. It falls way in that direction. So this recognition here, 1.8 times 10 to the first, or 18, is not going to work on this number line and is not a value that falls between 1.7 times 10 to the 0 and 195%. So I'll go ahead and cross that one out. All right, let's try 1 and 7/8. So 1 and 7/8. It's almost already a decimal. All we need to do is turn 7/8 into a decimal. And to do that, I'm going to go ahead and use my calculator and simply divide 7 by 8, and then take 7 divided by 8 as a decimal value, and rewrite my mixed number as a decimal. So instead of 1 and 7/8, it's 1.875. So this 7/8 just turned into a 0.875. Okay, so now when I graph 1.875 on my number line, 1.875 is somewhere bigger than 1.8, but not quite 1.9. So maybe you fall somewhere in this neighborhood right here, which is clearly between this blue dot and this blue dot. So 1.7/8 is one of my answers. All right, let's continue on. Let's look at 18.5. 18.5, sorry about that, my email likes to jump open all the time. 18.5 is already a decimal, so I don't really need to do anything to it other than recognize that it certainly does not fall between 1.7 and 1.7 and 1.95. it isn't even on our number line here. It falls way in that direction there. So I can cross that one out as well. And the last one we have here, 7/4. 7/4 converted to a decimal. If I use my calculator, simply divide 7 by 4 and we get 1.75. 1.75 graphed on our little number line here. 1.75 falls somewhere between 1.7 and 1.8, maybe like in this neighborhood right here, which clearly is between these two blue dots. So 7/4 or 1.75 is another correct answer. So we've identified these two as correct and these two as not correct. I would say one of the most common mistakes students would make on this question is not carefully reading what it's asking for. It's asking for identifying each number. So any one of these could be a possibility, not just one. So I would think a lot of students who might miss this question would discover this as a correct answer and then stop looking. They've said, well, I found one, so I guess I'm done, rather than continuing to check the rest of them and not connecting to the fact that 7/4 is also a value that lies between 1.7 times 10 to the 0 and 195%. So please, when you're doing problems like this, be very careful to check to make sure every possible answer is considered. Okay, thanks for watching, everybody.